Welcome back to another Ramda JS video, and in this video we are going to talk about equality, not in the sort of political sense of course, but in the functional programming sense, in the sense of value equality versus reference equality. In other words, are two things pointing to the same place in memory, or are they the same structurally? That's sort of the terminology that we've been using throughout this series when talking about equality. So if you have two variables and they point to the same location in memory, then you might say that those things are sort of reference equal. They have the same reference. They are pointing to actually the same thing. But in functional programming, and that's sort of commonly used in object-oriented programming, right? Where it's like you have an instance of an object, or sorry, you have an object, so an instance of a class, or you have two of them, and then you want to say, well, does this object equal this other object, right? Like, let's say you have a list of objects and you want to remove some particular object from that list. Well, if it's a question of reference equality, then you're only removing the ones that actually point to the same exact memory location. So this is simple because this makes equality checks very simple, right? You just simply say, is this the same memory location? Like, is this equals the same thing? And you don't have to implement any sort of recursive traversal over a structure to determine whether the object is truly in its full depth the same as this other object. So what I mean is, like, let's consider, for example, two JavaScript objects. So if you have a JavaScript object, let me just jump into Node here to make this a bit more clear. If you have a JavaScript object with a key foo pointing to 1 and the key bar pointing to the value 2, then if you want to check whether that thing, let's say, is that object equal to this other object with the same key foo pointing to the value 1 and the same key bar pointing to the value 2. In JavaScript, of course, those things are unequal because JavaScript has sort of loosely defined, or I mean, I'm using the terminology loosely. It has a reference equality, or equals is implemented as sort of a checker for reference equality. And of course, these two are not the same objects because here I just created the first literal and then I just created the other literal. By the way, sorry, before I forget, let me just mention that in the last video I posted a few questions in the end, and thanks to you, Eddie, who pointed out a few solutions to that question. So again, kudos to all of you people who are following this series. I'm happy to be on this journey with you guys. Very, very helpful to get insights from other people as we go through this like massive Ramda library is what I'm trying to say. Okay, anyways, let's get back into this video. Okay, so clearly these things are not equal, right? JavaScript is saying that they are not the same, and of course, if I do not equals, then that's true. But that's again because we are talking about reference equality, but actually structurally these are the same thing, right? I mean, it in some sense these are the same. Like, this should be true because we're saying if you have an object with a key foo pointing to the value 1 and the key bar pointing to the value 2, then that should be equal to another object with exactly the same structure. It just depends sort of on your viewpoint. But in my mind, it seems to me that in functional programming it's often very useful to make use of structural equality rather than object equality, especially because we're not mutating objects, but rather we just keep reconstructing new objects all the time, right? Think about that. Like, if you have an immutable list and you add an element to that immutable list, then you won't actually mutate that list such that the new element is in the list, but rather you return a new list that contains the old list plus the new item, right? So it's like you're actually producing a new list. And similarly for any structure, right? It's like if you have the string hello and you want to append the string world, then you get back a new string that contains the concatenation of hello and world, and not and the effect is not that you're mutating the original string hello such that you now have the word world in that first string as well. So you're not actually changing anything. And in that case, or in these cases, that means that our object, let's say memory locations, quotation marks, will change like all the time because we just keep producing new objects and new objects, right? So that's sort of the basics of value equality versus reference equality, and I'll get into the point I was mentioning before about having to compare things recursively. I just have to let the cat out. Hang on. All right. And so, I mean, even if we don't go into the, yeah, I mean, actually, we could even talk about the recursive, the need for some kind of recursion even here, maybe. But I mean, depends on the language that we're talking about. But yeah, so let's do the original case that I wanted to say. Let's say that instead of having that other structure, what if we had this structure where it's like the first object has a key called foo that points to a new object that contains a key called bar that then contains the value 1, right? So it's like this object inside of an object. Look at this for a moment, right? It's an object with a key foo pointing to another object that contains the key bar, and then you have the value 1. And of course, that thing, let me just, in order to not retype this, let me just copy that. That thing is also not equal to itself if I reproduce another object literal with the same structure in JavaScript. We get false back. But in a structural sense, of course, they are the same, right? Because, like, you can see, I mean, we've constructed the same thing twice. We just have two things in memory. We just have two sort of objects, but they actually contain all of the same stuff. But in order to construct a comparator, to compare whether these two things are structurally equivalent, we need to sort of check whether every primitive at every level of depth is equal. So we would have to say, well, let's traverse every property of this object. And in the first case, like when we had this flat object, we could say check the key foo against the key foo in the other object, and then check the key bar against the key bar in the other object. But now, since it's deep, we now have to say check the key foo and check the key foo in the other one. But then we have to sort of recursively unfold. So we have to call ourselves, because that thing inside of foo might also be something that if we check it against reference equality might also return false, but that would, according to value equality, return true. So hopefully I'm making sense, right? I'm just emphasizing that. Let's talk about lists instead, right? Because that's syntax is a bit less tiers. Wait, I don't know if I'm using the word tiers here wrong. I mean less. Yeah, sorry, it's the opposite of tiers. Yeah, less verbose is what I meant. But anyways, so I mean, if you check this out, you have the list 1, 2, 3. Is that equal to another list 1, 2, 3, another array literal? It's not, right? Because there are two places in memory. But again, structurally they are somehow equivalent. So here we could just say, like, does every, like, if we know that it's a flat list, we could just like do a for loop and then like check the length of the number of elements, or I mean, yeah, the number of elements in the list, and then just say, does the index 0 equal index 0 in the other list? Does the element at the index 1 equal the element at the index 1 in the other list, and so forth, like up to element n. But of course, it's not that simple, because we might have like an infinitely deep list. Like we might have a list of lists. So what if we have this, right? It's a list of, or maybe let me make something that makes a bit more sense. What if we have this, right? Where it's like 1 in the first inner list, 2 in the second inner list, and then 3 in the last inner list. But then, I mean, we could also have this, right? We could just keep on. We could have like infinitely deep lists. And so even, I mean, even if we just talk about empty lists, maybe that's actually a bit interesting, right? It's like, even if we have this, let me just, sorry, simultaneous capacity. Even if we have that list, right? It just seems sort of trivial to compare that list against itself, or another construction of, or another array literal, or another instantiation of a list with the same structure. But of course that's also true. It doesn't really matter that they're empty. Like JavaScript just says, of course these don't point to the same place in memory, so whatever. But again, those are in some terms, some sense equal, but you have to recursively compare it, and that's, I mean, I think if you're watching this series, you probably have a good idea of how to do that. If not, shoot something in the comments, and then maybe we can, maybe I'll make a video on recursion or something like that. I mean, but try it out. I mean, you'll definitely figure it out if you're not already intimately familiar with recursion. But let's now get into the more interesting parts, right? So I'm not gonna, maybe what I should say is that, okay, so wait, here's the end I should have started in. We are going to talk about equals by, I'll say equals even though the name of the function is eq, right? So eqBy, but equals by. And then we're going to talk about equals props, and then we're going to talk about equals. And then I think, yeah, the other ones we're going to take when they show up. Sequence is just shown here because it matches the word eq that I put in here in the search bar to find these functions, but there's also path equals, prop equals, and where equals, but we'll talk about those later, right? So I guess, I mean, it makes sense to just start with equals. And again, like we know this signature, right? Because it's like, well, if you pass something of type A and you pass something of type B, then you get back a Boolean. And the reason this is not like something of type A and something of type A, which it would be in like a strongly typed language, probably, is because you can have sort of truthy, and like what I mean is this: you can compare, let's say, the string 1, does that equal the number 1? And actually in JavaScript that's true. Let me just check. Does the number 1 equal string 1? Yeah, sorry. I mean, sometimes you get a bit surprising behavior, and then you have to figure out why that is. But as you can see, I mean, that actually works. So that means, I mean, and of course the string 1 doesn't have the same type as the number 1, so you can actually compare across types. And yeah, so that's why we have this sort of A-B rather than A to B to Boolean rather than A to Boolean. Anyways, and of course the definition here is straightforward. Equals returns true if its arguments are equivalent, false otherwise. Handles cyclical data structures. This is the key point, right? This is exactly what we talked about when we have these lists of lists, or when we have these objects containing objects, or like any mix in between here, of course, right? I mean, of course, we could mix objects and lists. And of course, like now I'm just sticking to like things of the same structure, but in JavaScript you can of course mix. So you have, I mean, since it's a dynamic language, so you can have like you can have an array that mixes the types on the same level, right? So it's like it's an array of the number 1, the string foo, and an empty object, right? Like, I mean, that's a totally valid array in JavaScript. And if you ask, again, whether that's equal to another construction containing the same data, that's of course false because they're not memory equal. But if you do that using R.equals, let's now get into that, right? Oops, actually, I've forgotten to load Ramda, so I need to load Ramda first. Let's just say require Ramda into R, and then R.equals, yep, we have that. So let me just do this again. So let's assume we have those two things, those sort of mixed arrays, and instead of doing equals, we'll pass these as 2 arguments to the function R.equals, and then of course we get true, right? Because they are structurally equivalent. But if I would change this, let's say the string foo in the second argument to O rather than O, now they're not equal because structurally they're not equal. And the point here about handle cyclical data structures is that your array, your object or whatever could be infinitely deep, and Ramda would still be able to figure out where that deviation between the two things are. So again, let's do these 2 lists, right, that we had before. So let's just copy this stuff. Let me remove that. New line. Whoops, did I not copy it? Let me try that again. Copy, paste. Okay, so from the beginning, R.equals, does this massive list equal this other massive list? And close parentheses. Let me run that and I'll just get the cat. Okay, sorry about that. Let's see. Yeah, all good. So, okay. And so that's equals, or that's equal, right? Those 2 massive arrays are both equal to each other. And even if we would stick some numbers in here, of course, that would work as well, right? So 1, 2, 3, 1, 2, and 3. That works as well, of course. And again, like we can mix structures, we can mix different types, because again, JavaScript, or rather, sorry, again, a dynamically typed language, that's true as well. Like these are still equal, right? But again, like regardless of where in this sort of nested series of things you change an element so that the two things are not structurally equivalent, you'll get back false, right? Wherever that is, Ramda will find it. Of course, if you have your own data structures, they need to implement equals, as you can see that they say here. Dispatches symmetrically to the equals methods of both arguments if present. So if you are passing a structure, like let's say you have a person class, you have an instance of a person class and you've defined the person class yourself, then Ramda can't compare people, right? So then they'll resort to reference equality, because that's like, how would they do it? Because you've defined it, so they have no idea what equality means for your class. So then you have to define the instance method equals so that they can dispatch to that. So I guess they'll check, actually let's go into the source and check that first. I guess they will check equals, like the existence of equals, before they before they resort to reference equality. Yeah, okay, so this is going to be a bit tricky because we have to dig into the internals here, because equals isn't like implemented here, but it's reused across Ramda. So they've defined it elsewhere because they want to be able to reuse it, which, I mean, makes a ton of sense. But let's just quickly see if we can understand that. If not, then let's just drop that, right? But yeah, I mean, as you can see, right, like defining recursive structure equality isn't like, I mean, yes, it's trivial, and no, it's not trivial, right? It's like, it's in some sense, of course, it's trivial, right? It's like, it's not difficult. It's just tedious. Let's say, maybe that's a better way of thinking about it, right? It's like, it requires a lot of code because you want to cover a lot of cases, right? And you want to get it right? So as you can see here, right, this is a lot of stuff, right? They're even like, this is pretty cool. I've never seen this, right? It seems like they're actually even supporting regular expressions. Is that the case? Type A. Yeah, I think so. That's pretty cool. That we need to dig into that some other time. I've never even thought about the ability to compare regular expressions. This is too cool. We have to try it. Okay, let's see. If I make a regular expression, let's say from A to Z, is it like something like that? Any repetitions of that, or maybe let's say plus, right? Yeah, that's a valid regular expression. So of course, if I say, is that equal to itself, like that, then that's false. But if I say like this, if I pass that to R.equals, that's true. Wow, that is pretty cool, actually. And if I change this to star, yeah, wow, okay, that thought has never crossed my mind, the ability to be able to compare regular expressions. I honestly have no idea how they're doing that. And like, even just spontaneously, I mean, I haven't looked at this before, but just looking at that sort of spontaneously, no, but of course, oops, sorry if that came out really loud. I accidentally hit the microphone. So maybe it's actually just ignore case, multi-line, stick, yeah, Unicode. So actually what's happening is probably that there's just a string representation. So if I have this regex, if I say .unicode, no, okay, so multi-line, yeah, so it's a bunch of properties that they're checking, like, does all the properties match? But I guess they would have to check like the string at some point. Source, yeah, okay, sorry. Sorry, okay, so the last thing I'm checking. Okay, so source is just a string representation. So actually, it seems like they're of course not checking if two regular expressions have the same effect, right? Because you might be able to express exactly the same, like, how am I going to put this, right? Like a regular expression with exactly the same effect, a regular expression that does like literally exactly the same thing, that has the same mapping from input to output, right? It's the same function. Like that regular expression has the same image, right? It's like, regardless of the things that you pass it, you'll always get the same things as the other regular expression. So in some sense, then that would be equivalent to the other regular expression. But then again, like, maybe you could argue that that's not structurally equivalent, right? Maybe. I don't know. Depends. But yeah, it would seem to me that that's not what's happening here, right? Because they're actually comparing the string. But anyways, that was pretty cool. I never thought about the fact that you could compare regular expressions. But okay, so that works, and there's a bunch of stuff here. What were we actually looking for? Now I'm pretty confused. Okay, so we were talking about when they resort to reference equality. When they dispatch to an equals method if it exists. So that should happen pretty early, right? Yep, here. Okay, so you can see, let's just sort of skim the code. A bunch of imports. They're defining the function. Array from iterator includes with if A contains an element that is not yeah, they're doing a bunch of no, actually, sorry, no, this is just the definition of a function that they'll use later, and here the function that they're exporting actually starts. So then we're just seeing that they're checking like object is, yeah, this I don't even know. So there's some another internal method that they have here, or another internal function that's called object is. Let's not dig into what that is, but that's sort of an early escape where they just say true, like they just return with equality if that thing is true. And then they start to do all the type checking to figure out, like, because it's a dynamic language, so they have to figure out what you've passed it, right? Because so and here you might interject and you might say, hey, but what about duck typing? I mean, we're in a dynamic language, and I agree, right? That's what should be going on, but that is what's going on when they are delegating to if you've implemented a Fantasyland compatible equals method, or if you've implemented an equals method, then they'll dispatch that, and then we are in the business of doing duck typing. But since all JavaScript types are not objects in some sense, right? Objects that support the equals method, right? Because like regex, or actually maybe they do. Sorry, actually you could maybe argue that they. Yeah, okay. Sorry, I don't know enough about JavaScript to say that. I was going to say that was the issue, but that's actually not the issue. The issue is that the default implementation of equality in JavaScript is written on the basis of reference equality rather than value equality. But even if it was written in terms of value equality, the issue could be that we can't dispatch to an equals method of some given object, because that thing might not actually be an object. It might be like a primitive. So I have to let another cat in, but please have a look at these two things. Like, this piece is the key of what the discussion or the question we were asking before. Okay, somebody mentioned in my observer pattern video that it's like I'm an observer of the cats because I just keep, I mean, I've subscribed to them. I just run around back and forth and let them in and out, which is totally true. But anyways, that's a side topic. Okay, so here is the key to the discussion that we were having before. In other words, when does Ramda resort to, actually, I mean, I was going to say, when does Ramda resort to reference equality? But the question I should have asked is when, in terms of the function, like at what step do they check whether you've implemented an equals method and then dispatch that? And that's here, right? So it's like, it's almost the first thing that they do, except that maybe, yeah, I mean, here it's like, well, they're checking if you've passed things. If you've passed two things of different types, then they can't possibly be equal, which is actually a bit strange. Let's think about that. If type A is strictly not the type of B, so then actually R.equals, let me just try to figure out. Is this actually not equals in? Yeah, okay, so that's interesting, right? So Ramda here makes a decision to not go down the JavaScript path of sort of somehow casting the string 1 to be a number when compared to a number, or vice versa. They actually say if you pass things that are actually of different types, then they are not equal, right? Unless, of course, you've passed something. No, yeah, exactly. Then they are not equal. Even if you implement the equals method, because they dispatch to the equals method after they've checked whether the types are different. So that's pretty interesting, I would say. But then actually maybe, okay, so sorry, now we have to figure this out. If you have, because of inheritance, right? Yeah, okay, let's not go down this path. But the path one should go down is if you ask the type, if you type check using type here, actually, is that their implementation of type? Yeah, okay, it's actually their implementation of type. So then that's a question of like how that even works. Because what I was going to say is that if you have a class that inherits from another class, so you have a child class that inherits from a parent class, and if you have an instance of that child class, and then you ask for the type of an object of that child class, then will you get will you get the child class or will you get the parent class? I mean, I would assume that you get the child class, and if you're then comparing across children that have the same parent, then in some sense you could say that that should be a scenario where they have the same type because they have the same ancestor. Because so it's like you have cat and dog and they are both animals. If you compare a cat and a dog, then you could argue that they should be compared on the basis of animal, if animal has the implementation of equals and not cats and dogs, right? So it's like, I mean, this would be more obvious in a statically typed language, because then you're comparing them as animals and not as a cat and as a dog, because it's obvious that if you compare them as a cat and a dog, then they're not the same thing, right? But if you're comparing them as animals, they might be the same thing. But yeah, even though, I mean, I see the argument that yeah, that's a totally strange scenario, and it makes sense to actually compare them as children. Or I mean, along the children type. So I just jumped into the source of type here just to see what, like, get an understanding of what they're doing there. Like, are they, yeah, they're checking the prototype of an object. Let's super quickly jump into this. Inheritance, JavaScript. Let's just see. I mean, since we have classes now, I guess like we have normal quotation marks inheritance. Yeah, sorry, this is, I should drop this because my understanding of JavaScript, I mean, I've like never actually worked with inheritance in JavaScript. I've hardly even worked with classes, right? I just use prototypes all the time because they do the same thing and like they're pretty compact. Let's drop this. As usual, that's an open question, and if you have the answer, please do shoot something in the comments, right? Will we, when we compare, when we ask whether two things are equal, whoops, sorry, here. When we ask whether two things are equal and they are subtypes, but the equals method is implemented in the parent type, will we end up here or will we end up here, right? Will the answer of whether the two things are equal inevitably be false because they are of different types, because they're of different subtypes, or will we actually dispatch to the parents equals method? That's an interesting question, but I don't want to waste your time with that, so let's keep moving forward. Okay. So, but in regards to like more normal scenarios where, for example, we have this, we're comparing the string 1 to another 1, then they'll dispatch to the equals method, right? So so what was the point we were looking for, right? Yeah, the point is that then, yeah, right. When do they resort to regular old equality, right? I guess in like somewhere here, maybe it's not even as simple, because at some point here, values of other types. Yeah, okay. Values of other types are only equal if identical. So then actually they must be checking triple equals at some point here, right? So they must be returning early if the two things are actually strictly equal. Object, but then maybe that's caught here. Yeah, let me drop this. Yeah, they're gonna do strict equality at some point here, which then will be reference equality. Yeah, I'm a bit. So because I'm just searching for return true, right? So here we return true in the end. and here we return true. Yaha, no, okay, so here's what I think is going on, right? So what they're doing is that they are eliminating the possibility that they are not the same. And in the end, the only thing that's left then is to return true. Because if you've eliminated every way in which they can't be the same, then the only thing that's left is reference equality. Probably it's something like that, right? So the last thing that's happening, quotation marks, is this sort of reference equality check, which isn't actually a check, but it's just the default of that we've exhausted every other option for them being unequal. Something along those lines, I guess. Okay, let's keep moving, right? so that's equals. And then some variants of this is equals by and equals props. So let's talk about equals by. So equals by, notice here you have this a more stricter type definition because we have a to Boolean. But in the beginning here they have a function from a to b. And let's just read the definition here first. So the definition of equals by is that it takes a function and two values in its domain and returns true if the values map to the same value in the codomain, false otherwise. So if you're a mathematician or if you've studied some math, you know exactly what this means. I always have to look this stuff up because I haven't studied enough math, not map. But the point is that you can think of a function. So here Wikipedia is depicting a function. So depicting the function f as a thing that's mapping from the domain of x's, so from the domain x to the domain of y's, right? To the domain y here, like capital X to capital Y. And I mean, clearly, if you've understood type definitions in Ramda, then you obviously understand this as well, because it's like the same thing. It's just that here they're talking about domain and codomain, but we just talk about types, right? It's like for us, a domain is a type, roughly speaking. So X here, so when we say, for example, that we have like the function add, right? So the function add in this case would be, the name add would be f here, so the function is add, and the domain x would be int, let's say, right? Okay, actually it's more like number, right? But let's say we have a function that adds integers, then x here would be int, and then y here would also be int. And then you have this further complication with this yellow portion of the image. We don't need to talk about the image now because we only need to care about the codomain. But the image is like the values that the function actually maps to. So for every, so I mean, you can think about it this way. It's possible that, so let's think about math problems, right? It's possible that you can't, with the function, end up at some particular values. Like let's say, I don't know. For some reason, you can't end up at the number 0. I was going to say pi, but then we have to talk about things others than ints and whatever. But let's say like you have a, all right, let's say you are defining the function add1, for example, right? That's actually the function add1, and the domain is positive integers from 0. So, like including 0. So I mean, I understand that we don't really have that type, but that would mean, okay, wait, this is too stupid. Let me just say that let's make a more simple scenario. Let's say that we have the domain of numbers, and our codomain is the domain of numbers. So it's number to number. Yeah. So it's the signature of the function is number to number. So let's say that we implement it as identity, as that actually, let's build a function. So we have this function, let's say let f be a function that takes some x, and if x is equal to 0, then we return 1. Otherwise we return x. So it's just sort of identity. Wait. If x is equal to 0, then we return 1, otherwise we return x, right? So if I then run x on 1, we get 1. If I run it on 200, we get 200. But if I run it on 0, we get 1, like for some odd reason. So that means 1 is in this blue area, or like this purple area of the y codomain here. So you can't map to 1, and all of the numbers except 0 is in the image here. But anyways, this turned into a math discussion. So that's just like a domain and codomain and image, and that totally helps us understand what they're saying here, because then they're actually being very precise about the implementation of equals by. So equals by says that if you take a function and you take two values and you map that, or sorry, and you run the values through that function, right? Then the function will map from the original values to some value in the codomain, from some value in the domain to some value in the codomain. And if the values in the codomain are equal, then they're considered to be equal. And I think actually their example here is a pretty great example, right? Because that's a pretty sensible scenario. Like you might actually find yourself in something like that. Like they're saying if you pass as a function math.abs, which is absolute, so turning all numbers into positive numbers, and then you pass 5 and then you pass -5, then of course you get true. But if you just say equals 5 and -5, then obviously you get false, right? So that's a pretty useful scenario. Another useful scenario I find is using, for example, math.round, right? So if you say equal by math.round, and then you pass, let's say 5.5 and 5.7 and 6, right? Oh, actually, wait, can I do, no, I can't do 3 numbers, sorry. So like this, right? 5.5 and 6, those are equal, right? But if you pass 5.4 and 6, then those are not equal if the function that we are using to map from the domain to the codomain is math.round. Sorry, I have to help the cats again. Okay, but hopefully you can see how that's a pretty useful scenario or example, right? Because you might for sure actually use something like that. And I think also what's pretty interesting I find is that let's say you have 2 lists of numbers instead, right? So like let's say we have 5.4, 5.3, 5.2. Oops, sorry, I used the wrong symbol. 5.4, 5.3, 5.2, 5.1. And then let's say you have, so that those are actually, let's just do 3 numbers. And then you have another list, which is just some other 5-point numbers, right? 5.4, 5.3, something like that, right? If you say, are those 2 things equal? Then they're actually equal, right? Because you're using, wait, actually, I'm a bit surprised. I was thinking that this can't be, wow, that is pretty cool. Hang on, I was thinking that we're gonna have to use map, but we don't have to use map. They're just actually equal anyway because we're using math.round. Let's just check that this is actually, no, okay, so there's something strange going on here. Equal by math.round. Yeah, sorry, okay, so they're equal according to math.round because probably math.round for some reason, yeah, sorry, okay, no, okay, that would have been too magic, right? Math.round gives us not a number, and JavaScript is actually, or sorry, JavaScript says that not a number is not equal to not a number, which is this extremely odd behavior that I didn't know about, but we discovered while I was debugging in another video. But probably since they're using R.equals under the hood, not a number and not a number using R.equals, yeah, is probably true, right? Or is true, which is totally the expected behavior, let me just say, right? Oh yeah, I mean, it depends on how you look at it, right? I mean, if you come from a reference value or reference equality point of view, then maybe it makes sense that they're not equal because they are not a number representations of 2 different numbers, potentially, or like, yeah, potentially 2 different numbers. Anyways, we're actually like, you can't guarantee that it's not a number stemming from the same number, but that's an odd discussion, right? It would just be easier if not a number was equal to not a number. But anyways, okay, so what happened here when we said equals by and then we passed these 2 lists is that we evaluated both of these lists to not a number. Like the codomain includes not a number if we since the input domain, since it's a dynamic language, right? It's like the input domain of math.round is like every possible value. It's like all types, but some of the types will map to not a number. So like if you pass math.round not things that aren't numbers such as arrays, then you can't expect to get a number back. So that's why that happened. But what we could do is that we could make this true for the correct reason. So we could simply just use r.map and say, well, the codomain that I want to use here, I should say the mapping function that I want to use here is the mapping of math.round. So I want to say the value I want to compare when the values that I want to compare are the values that I get back when mapping the function math.round over these two lists, right? So it's like rounding every number in these two lists. So you can see we get true if we run that, and then if we put another number which sort of breaks this equality, like we put a number that will be rounded up to 6 rather than be rounded down to 5, then that's false. And that I'd say is pretty cool. That's totally useful, right? Like I can think of scenarios where it's like you have like so again, like in my daily work I work a lot with simulation. So I'm a PhD student, and you might have, so I work a bit in R, right? So it's like you have this vector of numbers, and then you have another vector of numbers, and then maybe, yeah, I mean, okay, maybe it's a bit arbitrary, but like then maybe you want to check if these two things are equal, but for some reason the measurements are slightly off or something like that, or it's like, actually, I mean, it's not like the measurements are slightly off, like maybe you have just too many decimals, right? Because so sometimes I'm sampling uniform distributions and I just get tons of decimals, and then you just want to get rid of some of the decimals and check whether they are the same number. And then you could do that for a bunch of numbers at the same time. I mean, obviously this is not R, this is JavaScript, but I'm just saying, like, that's one potential scenario of where something like this might make sense. And of course, what's interesting here also, I think is pretty interesting, is that you can actually say, if you have something which is a functor, we've talked a bit about functors before, then that means that that thing will implement map, which means that you now have the capacity to actually compare things that aren't even supported by equals, because you can extract or you can map a function over the thing that's in the box, right? So like we talked a bit about having a box, right? Or having like the identity functor. So if you have something that's inside of an identity functor, then you could compare that by mapping, and then somehow, no, but wait a minute. No, they still have to be, no, I'm wrong. They still, of course, need to implement the equals method. Of course, they need to implement the equals method, because that's, like, I got quiet because it's like, it's exactly the problem of why when we talked about applicative functors, I can't remember which function we talked about, but there was we were discussing the reason why we need to have an applicative functor and not just a functor, and the reason there was that you want to avoid this sort of, like, you can't extract a value out from a functor. You can only actually map a function over it, but you can't get the raw value out, right? Because that could be any type. All right, I shouldn't say because that could be any type. I don't know if that's the reason, but like that's not part of the requirements of a functor. Anyways, I don't think. Let's just check that that's not it, right? So Fantasyland specification. We could just check Haskell docs or whatever, but since we're in JavaScript, right, let's use the Fantasyland specification. I'll pull this up and then I'll just let another cat in because they are going crazy. So functor and the maps, wait, okay, let me let the cat in, you read this. Okay, some pretty crazy cats. So functor needs the map method, And a contra map method. Yeah, this I have actually never looked into, but that seems to be something else. No, wait, that's a different type. Sorry, okay. Okay, so functor actually only needs map, right? That's why I was so confused. So contravariant is a different type class. Let me just check this. Yep, all good. So yeah, I mean, you only need the map function, which means clearly we can't get the value out of a functor, which means we're sort of stuck in this sense. Like if you would have your own defined functor, such as person, for example, then you won't be able to extract the contents of person or like box, right? Or like, let's say, array. You won't be able to extract the contents out. The reason this works that we are looking at now is because equals also works on arrays. But if you then have a type such as person that implements the equals method, you can then also use equals by if it's also a functor, right? So that's pretty interesting, I would say. Like, let's say you have a person. Let's say you have a person and you can map over that person. And I mean, I don't know what this map function does. Like probably person is a bad example. So so I'm hesitating to say box again because I should find a better example. But like, let's just say that you have this arbitrary box, right? You have this boxed value. Let's say, I mean, so maybe you have a maybe, for example. Actually, yeah, maybe you have a maybe, right? So do we have maybe in Ramda? No. But Fantasyland has maybe, right? Or yeah, I mean, wait, what? Wait. No, wait, but that's no, of course, because Fantasyland is on a higher level. Sorry, my bad. If you have something like, what is that called, like Sanctuary, for example, they probably have maybe type. Okay, let's go back to where we're here. Functor and then Ramda, we were at eqBy, right? Or eqBy. So if you have a maybe type, right, that makes sense because then you could say it's maybe a number or it's not, let's say. And you can map over a maybe, and you can do equals on a maybe if you implement equals on your maybe, right? Which might make sense, right? I mean, it's sensible to say, does this thing equal this other thing or not? And if you had that, then you could actually sort of do exactly this. Like, let's say you had a list of maybe round fraction numbers, right? Like decimal numbers. And then you could map, let's think about this. You would map the mapping of math.round. So the first map would be because you want to do it for all items in the list. And then the second map would be because you want to do it for whether it's for the maybe, right? For the functor of the maybe, because maybe you have a value that you can map the function over, and maybe you don't have a value that you can map the function over. And then we would get back a new list of maybes of numbers that you would be able to check equality on. Okay. I think we'll leave that at that. Hopefully that makes sense. But that's pretty cool, right? And hopefully now you're seeing how this sort of unification of interfaces using something like the Fantasyland specification makes a lot of sense, because we can sort of start to reason about the similarities between lots of different things and reuse code across lots of different domains. So let's, before we wrap this up, let's also talk about equals props, and I'll just let another cat out. Okay, so in the interest of time, I'm going to be a bit quick here, but what we are looking at here is essentially, let's just read the definition, right? So R.eqProps reports whether two objects have the same value in R.equals terms for the specified property, useful as a curried predicate. So this is not like, it's a sort of different concept than what we had before, right? So initially we just looked at straight equality, like structural equality, and then we looked at structural equality after having applied a function, and now we are looking at, oh, actually, sorry, it's not a totally different thing in some sense. What you could say is that we are now looking at structural equality after applying the function props. So maybe am I mistaken, or can we implement? Yeah, let's look at that in a moment. I think maybe we could implement this in terms of R.eqBy, right? So if you just let's look at their example right here, right? So let's say you have this first object and then the second object, and clearly they are not equal because the value for A, like the value that the key A is pointing to in the both objects, those values are different. B, those values are different. C, those values are actually the same. But then D, those values are different. But then they're saying if you check whether they R.eqProps, right? Whether they are equal in terms of the property A, then you get back false. But if you check whether they are equal in terms of the property C, then you get true. And I think the easiest way to think about this is probably just to say, like, let's say we have person 1, let's just say P1, is someone with a name of, let's say, John, but the ID is 1. And then let's say let P2 is equal to someone also with an ID 1, but whose name is, let's say, uppercase John for some absurd reason. Or maybe it's like we have a bunch of other data and all of that stuff. Like it's like one is like a partial object and the other one is like a full object where we have like address and a bunch of other stuff, right? And then, of course, if you just use vanilla JavaScript, P1 is equal to P2, that's false. And if you use R.equals of P1 and P2, that's also false because they're not actually the same. I mean, the IDs are the same, but the names are different. But what you could do is you could then say, do they have the same property when we're checking the property ID, P1 and then pass P2, check that. And that's true, right? If we check the property name, that's of course not true. Let's actually check some arbitrary property. I'm just wondering about that. If we make up a property, yeah. So if you pick some arbitrary property that they don't have, so one has to be a bit careful about this, right? Then you probably get back undefined or something like that. Let's just see. If I have this empty property and I check for I have this empty object and I ask for foo, oop, that didn't actually work. That was surprising. If I have this, what if I do this? If I have the empty, whoops, this empty object and I ask for the property foo like that. No, wait, what? If I have an object with the property foo pointing to the value bar 1, and if I then say foo on that, well, okay, so maybe I'm just messing this up. So let me, why did I make it so complicated? We have the object P1, so if I ask P1 for ID, then we get that. If I ask P1 for the name, then we get that. But if I ask P1 for foo, yeah, okay, sorry. So this is the way I should have do it. Clearly, it seems I can't call an object on a object literal directly. Probably have to wrap it in parentheses or something like that. So like, let's just add a bunch of parentheses to see if that works. Yeah, okay, so I have to wrap it in parentheses. That was my mistake. It's just syntactical. But anyways, the point is that we have to be a bit careful because as we showed here, if you do equal in terms of props and then you pass a property which is non-existent, then you'll get undefined back, and then they'll compare undefined, and undefined is clearly equal to undefined, just like not a number is equal to not a number in terms of R.equals or in R.equals terms. But yeah, so that's fairly, again, like super duper useful, especially in I think this is like, in my mind, an especially good example, right? You have same thing, you have person 1, you have person 2, and then you compare them in terms of their ID, right? Makes perfect sense to me, right? It's like you have these two things and you just want to check whether some property is the same. Now, what just struck me when I started, or sorry, before I say that, let's look at the type definition here. So the type definition here is that you pass some k, which is the type of which is a key type, right? A type that's used in the construction of keys within both of these objects. Because then, so it's like k to an object of key value pairs where you have keys of k and values of v, to another object of key value pairs where you have objects or keys of k and values of v, to a boolean. So the key needs to be of the same type as the keys in these objects. But again, like this, it's a bit tricky because that, like, expressing I was going to say that expressing type definitions in dynamic languages sometimes becomes a bit fishy, but yeah, I mean, probably that. No, exactly, right? Because like you could pass empty object, right? And then it's not necessarily, yeah, it depends on how you define k. Let me not think about that now, right? But yeah, so you pass, so in terms of just passing whatever you, so in terms of what you pass the key first, and then you pass the first object, and then you pass the second object, right? So it's like it's a similar syntax to the one we've looked, or it's a similar type definition to the ones we looked at before, where but here these two things are hard coded as objects, right? Whereas previously we had A to Boolean, but now we have object to Boolean. Okay, before we wrap this up, let's just think about this. What I was thinking when I said, maybe this we can do ourselves, is it so that equalEqProps, like equals in terms of some property, is actually the same thing as saying equalBy R.prop given some particular property, right? So let's say ID, for example. If we do that and then pass P1 and P2, yep, then they are equal. But if we do that for name, then that's false, right? So I don't think they've actually implemented it that way, but we could implement it that way. And if they haven't, that's probably for, yeah, that's of course for performance reasons. So they're just actually saying equals, and then they're just extracting the properties directly, right? Because like, why have another layer of indirection when you know exactly what you need, and you're not optimizing for readability, but you're optimizing for performance. Like, that makes sense, right? But if we were sort of if we were not optimizing for performance, but we were defining this function ourselves, I would definitely define it this way, right? Where it's like, well, name here is some x, so it's like or it's like let eqBy, if we define it ourselves, be some function that takes some x and then passes that x into prop, and then into prop, and uses that as the function it runs through eqBy. So equals by. So equals by this property that's defined by the variable x that's being passed in as the first argument, right? Then we could use this eqBy, right? So eqBy name. Oh, sorry, I defined it as eqBy. Sorry, I meant to define it as eqProps, of course. Sorry. So let's actually give it a minute. Has equal. Or equal in terms of property, whatever. Let's just say, I was going to give it another name, but actually let's just keep eqProps, right? So then we can call this function eqProps on, and then pass maybe ID, and then P1 and then P2. And again, we get true. But if we pass if we pass the string name instead, if we're checking if they're equal in terms of the key name, then it's false, because clearly they're not, right? And yeah, hopefully that makes sense. And again, another exercise for the reader. If you want to give yourself a challenge, maybe try to figure out how to turn this function into a point-free function, right? So how to remove the argument x here and just use function composition in order to figure this out. We should for sure be able to do that, right? This is probably simpler than the other. Yeah, I'm just thinking this is probably simpler than the other scenario that we had before. Actually, this is maybe just a... Yeah, let me not think about that. Sorry, I'll get stuck. This is probably a lot simpler than last time. But anyways, let's wrap this up. I don't think we'll look at equality next time. Next time we will look at... next time we will look at evolve. Pretty cool stuff. Okay, I need to close this now. Okay, so thanks a ton for watching. Remember to hit the like button if you appreciate it, subscribe if you're not already subscribed, and I will see you in the next video.